Okay, we have two shortcuts today. We have angle, side, angle, and angle, angle, side. Again, they are written in a specific order that helps you understand where that side is going to be. So this one is two angles and the included side. It's written that way because that's the sandwich side. Like we talked about with side, angle, side, the angle was sandwiched. In this case, we have two angles that are congruent and the side is included or sandwiched between those two angles. So this is very similar to what we learned last time with the angle, side, angle. So remember we had something that looked like this, that had the angle that was sandwiched between the two sides. Very similar idea, but now we have a side sandwiched between two angles. So again, this is a shortcut that says that if you have an angle, side, angle relationship, that's enough to say that those triangles are congruent. The other relationship we have is angle, angle, side. Again, look the way it's written. The side is not sandwiched. So in this case, it says the non-included side. So if you have two angles that are congruent, this would be the included side that I just talked about a minute ago. The non-included side is not sandwiched. There's two scenarios that can work with this one. The one that I have pictured, and you can have another one where we have two sets of angles that are congruent. It could be this side. It also could be this side. So both of those are considered non-included angles and is an angle, angle, side relationship. Look at a couple of examples. So we need to state the third congruence needed in order to show these two triangles are congruent. So these are a little bit tricky. This first example says you have to use side, angle, side. They're giving you these two. We have to figure out what's missing. So use your diagram and mark it up. Tells us that DE and MN are congruent. Angle M and angle D are congruent. Well, what's missing to do side, angle, side? This is review from last time. So what's missing is DF and MO need to be congruent. So DF and MO, that's that angle that's sandwiched between the two sides. Similar picture here, or the same picture. This example is asking us to use angle, side, angle. So that side has to be sandwiched between two angles. What's given to us, DF and MO are congruent. Angle F and angle O are congruent. Well, we need a side that is sandwiched. In order for that side to be sandwiched, I would have to know that M and D are congruent. So the missing congruence is angle D and angle M have to be congruent. Be careful with these. My advice to you is to draw this picture for each of the problems, even if it's only given to you once, and mark up your diagram so you can figure out that unknown. Is it possible to show the two triangles are congruent? Well, just like we did with our last lesson, think about if there's anything that you know is congruent, but isn't marked. In this first case, we have these two marked as congruent and these angles. The only other thing we know is that WL is reflexive, which means it's congruent to itself. It's part of both your triangles. What I have here is an angle with two sides. This is not a congruence. This is an angle that's not sandwiched, and it's also two sides with an angle, and this one does not work. So there's no shortcut that allows us to say this is congruent. So the answer is no. Looking at this picture, again, thinking about anything that is congruent that's not marked. I see vertical angles, don't forget about those. There's nothing else that I can say is congruent. I can't say these are congruent, I can't say these are congruent. So looking at my picture, I have two angles with a non-included side. So this is angle, angle, side, which means that they are congruent. And I can write a statement, SUH, following my pattern, started in the middle and went to my one angle marking and then over to the no markings. So STN. And remember, you can write that more than one way. And I have a new idea for our proof today. So if you follow, I want to make this video a little shorter, so I already did this for you. These are my given statements, and I marked them in pink. DE and EC are congruent. ADE and BCE, that's these two statements in pink. From here, I need to show that the two triangles are congruent in order to show that these two parts are congruent. So let me explain. This says AED and BEC are congruent using vertical angles. That's my vertical angles theorem. Looking at those two blue triangles, which is where my focus is, I now have an angle-side angle relationship. That angle-side angle relationship allows me to say that the triangles are congruent. But if you look at the proof statement, we're not asked to show triangles are congruent. We're asked to show that DAE is congruent to, which is this angle right here, and is congruent to CBE, which is this angle. So notice what I just highlighted in orange is part of these two blue triangles that I just said is congruent. Now that I know the triangles are congruent, I know all the parts are congruent. So this is something new today. Because I know this triangle is congruent, this specific part, DAE and CBE, the orange, are congruent using CPCTC. This is something you'll use a lot. And it stands for corresponding parts of congruent triangles are congruent. This only works after you know the triangles are congruent. Once you know the triangles are congruent, all the corresponding parts are congruent. And that's a really helpful thing that you will use.